Hello and welcome to another edition of the EWI Technology Podcast. My name is Max Saran and I am here in chilly Columbus, Ohio, where I am loving the weather because I'm from chilly Canada, and we're having great interviews learning about all the technology and wonderful research that's happening here at EWI. Today I have here Logan McNeil, who is an applications engineer here in EWI, and we're going to be talking about lots of cool stuff. You're going to teach me stuff today, aren't you?
I'm going to try my best, so we'll see if I'm a good teacher or not.
How you doing, Logan?
Good. How about yourself?
I'm doing good. I'm doing good. It's this is a nice town. We had some good meals. It seems
Good.
like a pretty good place to be.
Yeah, I'm upset you think it's nice here because it's way too cold for me. So that's how I feel.
Well,
about
you were
it.
saying you're from Tennessee initially.
Tennessee originally. Yep.
So,
yeah.
and I mean, there's parts of Tennessee that get snow.
Oh, we get snow in the mountains and stuff, but it's just not negative. Feels like 2 degrees is a little too cold for me, but that's just me.
Yeah, no, I live in central Canada, so like the
Oh.
coldest part of
Yeah,
Canada.
the tundra.
Yeah, and the day I flew here, it was minus 26 Celsius, which is about minus
Ooh.
2 Fahrenheit.
Oh,
So that's cold.
yeah. No, that's a little colder than here.
No,
so-
it's actually more because I think they even out at minus 30.
yes.
I think
the
it's
same.
minus
Yeah,
30.
Yeah.
So that'd be more like minus
Minus
26
20. Yep.
something. Yeah,
Ooh,
that's
no.
cold. So I'm here. It's nice.
Yeah,
It's like
nice for
spring.
you. See, it's cold for us, right? So it's all relative. But
So how long have you been here at EWI?
yeah, I started fall 2021, so I've been here about 3 years at EWI, kind of working originally from Tennessee, like I mentioned. Worked, got my PhD at the University of Tennessee, working at Oak Ridge National Lab at the same time in their large scale additive group. So
And what did attract you to EWI? Like, what brought you up to this chilly area?
well, a lot of it was the people, right?
Yeah.
So obviously when you're trying to graduate and do all this stuff, you're talking to a lot of different people. But main thing is, EWI is seen kind of as thought leaders when it comes to especially the large scale manufacturing and when it comes to the welding and joining technologies. So that's what really attracted me. And a lot of the things here is, I'm sure a lot of my other people have mentioned it, but in a lot of ways, we get to kind of create the things that we want to and work on types of things that find interest and kind of try to push the technology forward in ways that make sense.
So what was your specialty coming out of college, like for your PhD? What was it that you were hoping to do for the rest of your life?
Yeah. So believe it or not, I started college as an undergrad thinking I wanted to be a medical doctor, right?
Oh, wow.
So I have a Yeah, exactly. No, but I started as a biomedical undergrad. But I really got into biorobotics is how I started, right?
Cool.
And
Yeah.
so when I went to grad school, my professor came to me and he just said, "Hey, how do you feel about large scale 3D printing?" And I said, "I don't know, sounds really fun. Let's just do it." So that's what I actually switched to mechanical engineering for my master's and PhD, and I worked on a lot of the robotics, the toolpath planning, kind of the in-process monitoring that comes with being able to do these large-scale prints for ARC DED type applications.
And there must be some crossover between those two disciplines of what you wanted. Like, I mean, over the course of this week in the interviews I've done here, I've learned that quite a bit of the work that's being done here is medically related.
Yeah.
To medical equipment, medical single-use products, safer, greener, more hygienic products. So, like, I mean, with the large-scale manufacturing and the individual product-specific research that's happening here, there's a wealth of connections there.
Yes. Yeah. I mean, that's one thing that I actually is my favorite part about EWI is, right, and I'm lucky because I'm more of a robotics guy, right, at my core, we'll say, even though I'm in the arc welding group, but I get to go work with the laser guys labs and they're welding battery tabs or medical devices. I go out to the the friction stir guys and they're doing these giant pieces of metal for aerospace, giant companies, things like that. And then I go to the ARC DED stuff. We're printing stuff for shipbuilding and propeller blades. So it's pretty fun because you get to see
pretty wide
everything.
range.
Oh yeah, it's great. So
then when you came in, what was the first kind of niche that you got placed into here at EWI?
Yeah. So what I started here was actually working on being able to kind of integrate the systems that are out there. So we've got about 12 different arc welding systems. I actually initially started working on a plasma and TIG DED system. So we've got a dual use power supply. We have it attached to a dual arm system where we did prints with those. We were working on a couple different materials, working on 3D printing with those in the system.
And for all the laymen out there that keep hearing you say DED, explain the process.
Yeah. So DED, directed energy deposition, right? So that's just a fancy way of saying that we put the material where it needs to go, right?
Yeah.
And so there's a couple different types of 3D printing modalities. There's laser powder bed. You put the powder in the machine, it does the laser on the top. drops it down, adds
what doesn't
powder.
stick comes off.
Exactly.
Yeah.
And then DED, which is all about you put the wire and the material in the place you need it to go. So, you got laser DED, arc DED, cold spray can be considered DED. It's just all about that.
And it's about trying to be efficient, have no wasted heat, reduce the amount of heat affected zone, all these things that in the welding world, in just a normal open arc process are kind of the big issues, right?
Exactly. Yeah, I see it as kind of like, honestly, the next evolution, right? And, they've been doing robotic welding for a long time, but, it's kind of the fun new technology, right? You're taking, we've been welding for hundreds of years, right? And it's like, let's robot it and put it on a robot and make it do fun shapes, right? So that's kind of the next stage.
I really feel like the jump happened recently. Because up until about, I would say, 5-6 years ago, the concept of automating welding was to mimic a human. So basically, you're just taking standard welding equipment, figuring out how to outfit it on a application or a automation application, and then having it mimic the human but faster.
Yes.
Right.
Yep.
Whereas now it's like no. Let's forget about those processes completely. Let's see what processes actually benefit from the accuracy and the speed of the robot as opposed to just trying to mimic a human quicker.
Exactly. Yeah. And that's, we've done a lot of stuff. Connie Reichert here has worked on our telewelding where we're being able to interpret that kind of stuff and put it on a robot. And while humans do things really well, you're really good at multi-sensor modality sensing, right? That's where
lots of information coming
with your eyes, your ears, all that stuff can be kind of fused together in your brain, right? And robots aren't good at that, right? That's why people are working on AI and stuff. But that's where you can, if you tailor the process and tailor the robot tool pathing and how you do it into that, you can get different efficiencies out of it, which are more appropriate. So
what are some of the projects that you've been working on here? Like I know some of it's like can't talk about it out loud, but just what are some of the cool things that you've been working on the last couple of years? Yeah.
A lot of the stuff is centered around that large scale manufacturing, right? And so it's a fancy buzzword, but we call it convergent manufacturing, right? And so really it's about multi-process systems, right? So if you go out here in our high bay, what you'll see is we've got systems. I've got a gantry system. It's about 50 feet by 15 feet by 12 feet tall is my build area. It was actually put in next to our friction stir system to have a tank drive in, right? Okay. So you can do weld repair and then do friction stir on it. But the side that I work on typically is more, we've got two different arc welding systems on it. We've got a laser welding DED system on it, and we've got a push core spindle so we can pick up and do machining and grinding.
And this is all within the same gantry space.
Yes, exactly. Yeah. So the idea of most of our projects center around that is how can we chain together kind of the workflows, but also have enough process knowledge to do things the first time to get all the things you just talked about, efficiency and near net shape and getting good part quality we begin with.
And then who's the end user of these, creations that get invented in these labs?
Yeah.
Because when we're talking about large scale manufacturing, large projects, automation of DED, welding, these are all specific niche type things, which I think eventually won't be so niche. But at this point, who's the customer base that can take on these amazing technologies?
Yeah, so you're seeing a huge resurgence in the U.S. in DoD spending and funding, right? I mean, we've offshored a lot of those large-scale capabilities, right? And a lot of the castings and forging houses, either have backups or, hey, they don't want to do the, as we jokingly call them, onesie-twosies, right? Building the tooling and having all that stuff available ready for them to be able to put new parts in. And also like rapid prototyping, right? Like with a lot of that stuff, it's, hey, we're not sure this is going to work. We just need one to test it out and make sure all the material properties are good before we actually come back to it. And so DoD's a big customer of ours, but you're seeing a lot in the heavy industries too. We work pretty closely with the steel foundries and casting. SFSA are our partners there on a couple different projects where we're working with those guys and they serve as heavy industry, right? Talking about the mining, those kinds of people, equipment trucks, things like that, just anything that's big and heavy. We typically serve a lot of those industries.
That's super interesting. In the city I live in Canada, Regina, we have a steel foundry. We have Everaz. And because we have Everaz, we're in a mining central area too, potash, uranium, diamonds, gold. And so my career has been heavy industry, mining, and working around the steel foundry and all the work that comes out of there. I see how these applications are so important because, number one, the plates are the materials are heavy. You're usually working on big, heavy materials that require intensive welding, usually in terrible spaces or areas. And often those locations, like the partnership between mining and foundries, is that they're always looking for that next new material or material combination that'll be less corrosive, have less oxidation, because especially in the potash industry, it doesn't matter what metal you use. It's
gonna go away. Yep. No, yeah, and I think you're seeing a big push. That's kind of the beauty to me about, I'll say 3D printing, but convergent manufacturing is that kind of that forward expeditionariness of it, right? So we've got some stuff we're working on, DOD wise, but also with the industries where, hey, it's hard to move those parts around, right? Yeah. So we would much rather make it in place or as close as possible to where it needs to go so that we don't have to transport it, right? And so that's what this flexibility gives you, right? If you've got to have all this infrastructure built in to do these giant castings and forgings and then get it to the place it needs to be assembled and move that around, that's what I've seen on some of the foundries that I've been to, is they talk about how for these 10-ton parts, right? Yeah. It takes longer to move it within the facility than it does to
find someone to move it.
If you can, it takes it longer to move within the facility than it does to do the actual things you need, like the surface grinding and finishing, the UT, the NDE inspection. Like, it's more about the moving, the logistics of that. So
now, you bring up inspection and quality control. Is that part of the systems that you're working within?
Yeah.
Because to do large scale manufacturing, I worked for a large manufacturing company in Canada for years. And we're talking like 4,000 welders, multiple robots, all the things. But QA really becomes a big deal when you're moving that much equipment through, right?
Yes, and we do a lot of that, a lot of different kind of work in there. And there's a couple different elements of that, right? There's the quality assurance side where, especially if you're, for our large scale ARC DED type stuff that we do, right? You're putting down, 700 layers of welds, right? You really need to make sure that
they're all good.
Yes, and especially the ones at the bottom, right? Because if you get all the way up, you're like, man, I just wasted all this time. And
then you learn how to gouge.
Well, that's right. Yeah, and you got to go back and repair.
Yeah.
But, a lot of that stuff is, again, back to that sensor fusion, right? But a lot of it, too, is, we have a long history at EWI of process expertise, right?
Yeah.
And I would not claim myself as one of the ones here that does all that, but we have lots of, Dennis Harwig, my senior technology leader for arc welding and DED, he has worked at, 30, 40 plus years in the arc welding space, and just about which variables do you monitor, what type of sensing can you put on it to ensure that things are good before and as it goes down. And then obviously you got to always do the post inspection. It doesn't matter what application it is, got to go back and do it, and we're working on automating that as well.
Yeah, because when you're talking about 700 layers, right, you need to almost have constant monitoring of that process throughout. And sometimes the issues or the discontinuities or the problems with a weld are not evident immediately.
Exactly.
Right? Sometimes it's during the annealing or cooling process. Sometimes things happen with the materials itself as they migrate or diffuse into each other. How do you mitigate that when you're working with this many layers? And then, I guess as a follow-up question, how do you make that a product to sell to a company so that you can ensure that they follow that process?
Yeah, exactly.
Yeah.
So, we spend a lot of time working on ICME. I don't know if anyone's mentioned that, but integrated computational materials engineering, right, is typically, and there's 100 different definitions of ICME, but, we do a ton of modeling when it comes to distortion prediction, right? That's the big one for larger scale stuff, right?
Yeah, everything's going to banana.
It's going to. It just happens, right? And, you can fixture it as much as you want, but at a certain extent, stress wins, right?
Yeah.
And so but that's the kind of the beauty about, for in this case, ARC or any type of DED application, is really I can predict and control that based on my tool pass, right? And also my heat input.
Yeah.
So you're able to tailor those, if you kind of understand the fundamentals when it comes back down to the base level physics and the microstructure. And so we spend a lot of time here focusing in on that process, right? So that localized weld pool is really important.
It's right on. It's dialed right in.
Yes, and so we dial that in. We understand, hey, this is what a good weld looks like, right? And then it's very easy to kind of build in the layer of control over top of that, such you can sense disturbances, right? What is you say, hey, why am I all of a sudden my voltage is a lot higher? Or why is my wire feed speed changing, right? Yeah. And so that's generally how we approach it from an in situ sense. But again, on the front end, that ICME, that computation, the modeling, that's typically where we try to push customers, right? Because you got to do your homework up front, right? Especially in these big cases. But as far as you asked about commercialization aspect of it, right? That's
because then it's out of your hands. That's kind of tricky, right?
Yes, yeah. So we are a not-for-profit, right? So, but we spend a lot of time in technical innovation. So we have a lot of great commercial partners, and there's a lot of great off-the-shelf tools that already exist, right? And so we try to leverage those as much as possible. And so when we try to do projects, we will try to find partners that help us and kind of take that further. But we also, again, I mentioned telewelding. We're working on a couple. I'm working on a couple patents right now that I can't talk about, but things like that we want to transition, and we want to find partners that help us transition those technologies because they're important, right? You know, and they're the kind of the crux to being able to do those types of things. And so that's always the hard part, is the tricky part, right? Is like how do we push that out into industry? Yeah,
the industry is it's going to be in a critical point in the next decade or so where we see we're always going to need the mon-pas. We're always going to need the local, welders, manufacturers, producers, the custom shops that are smaller scale to do a lot of the pickup work. But we're seeing an amalgamation of large companies around the world where they're really moving into centralized plants, large-scale manufacturing, large-scale automation. And like you're looking at places like Shenzhen where the whole city's automated, like right to the dock, which is unreal, right? When you start actually planning at that level. These type of technologies that you guys are working on here, do you see them in the future as being the standard?
We do. And actually that's a lot of our work here, because we are a not-for-profit and we try to kind of be the unbiased opinions about things, is like trying to either help establish or help kind of forge that initial path on what is the new standard, right? Yeah. How do we handle the new standard, right? You pick up a welding power supply, you buy it from a company, they need to be calibrated to be correct, right? Like what is that calibration procedure, right? Because just because I use this waveform with this wire feed speed and travel speed on this machine doesn't mean it's exactly the same.
No two machines are the same, ever.
Yeah. Yep. And so, and it, again, and that's where there's some doom and gloom, like automation's going to take over the world, AI is going to, change everything. And I truly believe it will be for the better, right? Because we already have a shortage, right? We already have, we need those mom and pop shops, and I want to make their lives easier, right? I don't want to make it harder on anybody. And actually I want to provide them tools that are, one, easy to use, and two, they want to use, because it's going to make them more money, make it easier on whatever it is, give them first-time quality, right? Reduce that rework.
Now, for someone that started off in the medical field and then got into robotics, you sure know a lot about welding. Yeah. How's that learning curve been for you coming into this industry?
Yeah, no, it's been a very interesting journey, right? And I think what's fun to me about welding is it's just so like multi-physical, right? I mean, you've got heat, you've got material input, you've got base level, you've got mixing of that, the phase transformations of the material science, right? Like it's really complicated. Like,
it touches every part of science.
Exactly.
Really.
Yeah. I mean, I actually just did a weld panel with Weld Australia recently, and we were talking about large scale AM. And, I think it's funny because we talk about like ARC DED and large scale convergent manufacturing type applications. And it's one of the few places where you have to make metallurgists, material scientists, roboticists, and welding engineers agree on the same thing, which is
that's a task.
Insanely hard, right? But it's I don't know. To me, that's what makes it fun, right? Is like being able to kind of span all of those and learn enough to be dangerous at everything. So
and when you bring in enough parts of the puzzle to come up with a solution, the answer is going to be more complete.
Exactly.
Right? Like the picture that's formed is going to be a more encompassing picture. As a not-for-profit, EWI has also like some goals within itself in terms of sustainability and in terms of, eco standards and producing, I guess, the resources that are needed to move these projects forward.
Exactly.
Where do you sit with all those pieces?
Yeah. So that's an interesting question. I think a lot of where I view, you got to be more efficient, right? And the more efficiency, there's different ways to be efficient.
Yeah,
right?
On the way in or on the way out.
Exactly, right? Yeah. And so how do you understand that and make the most sense for your workflow, right? For a lot of these large scale parts, right? it's better to start with a casting and forging, right? I mean, you shouldn't be, I can maybe arc DED weld at best. Oak Ridge National Lab is doing some stuff where we're printing over a little bit over 100 pounds per hour, right? But but that's nowhere really close to what a casting and something can be cast to begin with. Yeah, that's right. That's right.
Yeah.
And so how do you build in that whole workflow, and how do you examine the whole piece of it, right? From cradle to grave. And I think that's what's missing in a lot of even manufacturing environments, right? And it's more about awareness, right? Like you don't see those things, right? Most of the time a fabricator, they're getting these parts in and it's now stick them together, right? Mm-hmm. Like they didn't get a say on what the parts looked like before it arrived to them.
That's right.
And so I think it's more of an onus on I don't want to say the part designers because it's not just them, right? But we should be having conversations between the designers, between the people who are actually doing the process, to where the machinists, and even in the end users, right? Like because there's lots of cases where with the ARC DED, like, do I really need to finish and machine the surface? Right?
Yeah, is that part of the reason for it to exist? Yeah,
exactly. Yeah. And people too often, in my mind, try to just, we can throw 3D printing at it, right? And 3D print this part that already exists. Yeah, and it's like, well, it's probably better for you to fabricate it the other way. And so that's where, from my perspective, is I think there's just a lack of clarity, and it's mostly just awareness, right? The guy who's sticking stuff together and welding, he doesn't know, why some guy designed it this way, typically, right? He
gets a blueprint and a set of standards that he's got to hit, and that's that.
Exactly. Yeah. And so, like, for me, that's where I feel like I try to help here, right? Is like, because I'm not a process expert, right? Like I'm a robot guy. And so my job is to enable the process expertise to be automated in a way that's stable and makes sense. And so I think in kind of the same way, you're talking about the whole manufacturing environment, we've got to do a better job just overall, in the manufacturing industry of trying to identify and talk to each other at all levels to make sure we understand the real purpose so that we can build those efficiencies. It becomes more sustainable. And we do stuff that makes sense, right?
Yeah, and I think there's an image that's a little bit fell behind in the additive manufacturing world, because additive manufacturing has been around for a while, and it didn't really catch on. And I think a lot of it's an image problem. Yeah. You look at what someone says, and so like you get the professor from the AM college, and they said like, look, we built this flower vase, and we 3D printed it out of metal, and to all the engineers and all the people that work in AM, they're like, cool, that's awesome. To a welder and a machinist and a fabricator, they're like, that doesn't look good.
Exactly.
Right? That's rough. It's uneven. It's not sitting flat. They see all the things that are probably not the key components that you're actually supposed to be looking at.
Exactly.
So how do you bridge that gap between the public's view of how it looks or should be versus what's being done?
Yeah. So this is the key element, right? Yeah. And I think it is a perception problem, right? And it's again, we want to push technology, right? But we should be pushing technology where it makes sense, right? And that's something that I feel very strongly about is there is a tendency in the research world, and there's a tendency in more of the fundamental science. It's like, we need to do that, and we need to explore those spaces, right? But we try to fit that into an application where it doesn't make sense, right?
Yeah.
So properly identifying starts with that whole workflow, right? It's to say, hey, here's what this looks like. Here's what makes sense to do. Here's how we should do it.
Yeah.
And I feel at EWI, being an applied research center, right, we are lucky because I get to span that gap, right? Like the academics, the applied people, hey, we need to push this up to TRL level 9 so that we can actually put it in production. Understanding those real challenges, right? What does that make sense? And a lot of it is, for me, is AM should be viewed as another tool, right? It shouldn't.
It's in the toolbox.
It's another tool in the toolbox. When does it make sense to get out and get it? I don't know, right? But that's just all dependent on exactly the part, specific things, the materials. There's all of those checkpoints that have to be really thought about beforehand before just saying, oh, we'll just 3D print it, it'll be fine.
Yeah, and to all the welders listening, not everything is a hammer, okay? There is other tools, okay? Trust me. And then they're very cool, right?
Yes.
Now, for in the world of additive manufacturing, when you're looking at the products that are going to be going out, you're looking at, things that you can speed up industry, or are you looking more to build things that are going to be more supportive of industry? Do you understand the difference I'm trying to say there?
Yeah. No, I actually think it's should be more supportive, right? I think there is a lack currently with our current manufacturing environment domestically in the U.S., that we have to have some additive manufacturing pick up the slack, right?
Yeah.
But I think generally we should look at it the other way around, right? Because there's so many applications where you would be better redesigning the part if you're going to use additive than just printing the exact same part that was designed to be traditionally manufactured, right? And so that's sort of where I think that perception is lost, right? Is there's got to be a little bit of discussion on, hey, why is it this way? Hey, what is the purpose of this? Why are we treating this? But the other aspect of additive that I think is we're starting to see more, because I think, I'll say my generation has grown up with 3D printing, so we understand what you can and can't do with it and how to design for it.
Right.
That's something that additive gives you a little bit more than traditional manufacturing, right? You can put conformal cooling channels in things. You can have unique topology optimized designs that understand the stress states that within the part itself and what the loading is going to be. And that's just tools that are really only just becoming mature, right? We've been working on those for a long time, but they're only finally kind of being mature. And I just hope people understand that it's time to come back a little bit to look at those, but understand with an eye on, hey, why are we trying to do this, right?
Well, I love what you said there. It's not about making the same part with this new technology. It's about using the new technology to create a new version of that part that makes sense.
Exactly.
For me, and this might sound silly for someone who does what you do, but the biggest thing that made me change my mind with additive manufacturing as an old guy coming in being like, okay, I see now where this is going, is when they had an I-beam built. So they had just a standard wide flange 8-inch I-beam. This thing can hold, these are the stats. This is 400 pounds per feet it can hold. This is the twist it has on it, blah, blah, blah. Then they had the same outside dimension additive manufactured I-beam, but inside it was hollow with a hex structure.
Yep.
Like you've seen the picture of these things, right? And this same I-beam at a third the weight could hold 8 times the amount of pressure and no twist whatsoever. And then I thought, that's the thing. It's not about just making an I-beam with that machine. It's about making a new I-beam that we could never extrude. We could never do that in the foundry. This is a singular solution that additive manufacturing can provide that might be only the one I-beam in the building that you need. Not all. We're not saying all. Maybe 90% of the beams are like old traditional. But you want to do something cool, something with a curve, something that'll hold special weight. That one piece that is the crux of perhaps the whole thing can be built in a special lab in a special way with special technology and change the way we do construction.
Exactly.
So I just went off there. But
for
me, that was like a moment where I was like, okay, I'm getting it now.
Yes. Yeah. No, and I've been very lucky, like I said, working at Oak Ridge National Lab and seeing the kind of the evolution, right? I've been working kind of in that additive space now for over 10 years, right? Wow, between all that, and it's starting to mature in a good way, right? And luckily what I'm seeing now more than ever is that we're actually trying to go back and leverage the existing knowledge that welders have, right? I mean, because at the end of the day, ARC DED, right, is just a robotic welder, right?
Yeah.
So let's take all of those principles that we already know and we already have learned and just apply it, right? And the same thing is, let's bring in those elements of new design, of new understanding, hey, why was this part built for this reason, right? And then be able to change how we design and fabricate stuff, right? And then that allows you to optimize it, right? Now we can go back and say, hey, let's take off, 20% weight reduction. Right? I mean, weight reduction is a huge positive with anything that you want to do with additive.
Especially if you want to use traditional alloys, you can keep your material costs way down.
Exactly. Yep.
Now, what about in terms of, let's see if I can say this right, large-scale manufacturing of small-scale parts, right? Because that's kind of a place where AM hasn't been seen as being useful. Is that starting to change?
Yes, it is. And again, in my mind, so you talk about like the laser powder bed technologies, right? Those are the more mature ones. Those have been around even longer. DED is really just started within the past, at least in the U.S., right? There's been places like Cranfield University in the UK and others who have been doing WAM, wire arc additive, or arc DED for a long time. But really in the U.S. about 10 years ago, the pickup, Lincoln Electric has their Additive Solution Center in Cleveland where they are full-time printing. I believe they have over 40 arc DED printers that are running.
That's a cool location.
Yeah, okay, so you've been.
I've been,
So that they have some really great technology, and I think it's more about building trust in the process, right? I think that's what's been, you have to have, at least in the research world and even for manufacturers, you have to have that data, right? You have to have that proof. Yeah. And you also have to have the qualifications and the standards behind it that give people confidence to be able to adopt it, right?
Yeah, once you have the standards, then it's kind of a line drawn in the sand where are you like on this side or on that side?
Exactly. Yeah. And we've just seen, so NAVSEA, so the Navy in the U.S. have released their tech pub for wire arc additive. ASME Section 9 is doing theirs, and AWS is about to release, or if they haven't already, I think they might have released a version of it, from their D20 committee, standards behind how you qualify the process such that arc DED or 3D printed wire arc parts can be used.
PQRs with them. Yeah.
Exactly. Yep. So that's kind of, to me, what's been good is we are finally getting to the point with the DED crowd, right? That you don't have to take let me just do hundreds of tests, right, to say, hey, this is good, right? But building that confidence behind it.
Do the one test. Did you do it right? Good. Let's get in production.
Exactly.
Yeah.
Yep.
Now, what about stuff like dissimilar metals? That's something that's super huge now, like the alloy combinations. As we strip the planet of our resources, we are forced into corners where we have to start creating new alloys and versions of materials. We talked about polymers this week with a number of people here at EWI, and even polymers to metals. In the additive space, my belief or what my understanding is that problem is not as big of a deal. Like, are there solutions within this technology?
Yeah, I mean, you've seen dissimilar weld clads for how many years, right? I mean, and so I think that's where additive plays a huge role and is something that's actually another positive, right?
Yeah.
We back, I think it's been, Dennis Harwig would know, shape welding. That's what he talks about all the time. He's been doing shape welding, so printing structures and parts with weld metal since like the 80s, right?
Wow.
Structural buttering of close but dissimilar metals in the Navy sector, stuff like that.
Yeah, hard surfacing.
Exactly.
Yeah.
I mean, we've already been doing it, right?
Yeah.
And it's just a matter of being able to understand the material alloys and understand how those interactions happen, right? And so we are doing, frankly, quite a bit of work on the dissimilar materials, right? And Can
you layer it in? Like, let's say you're talking about that 700 layer example.
Yeah.
Could you have 30 layers of, A44 standard 70 tensile steel, and then you have, let's put in a little chrome, and then put in a little Morton steel, and then maybe a bronze. I mean, whatever the purpose of that might be. Is that a thing?
So it is not a thing yet, but we actually have some active projects where we're talking about in situ alloying, right?
Wow,
so that to me is kind of
if you can hit the diffusion rates right, why not? Right?
Exactly. Yep. And especially just I'm not a fundamental material scientist, right? But I know that especially when you get into steels, man, it's so complex, right? You tweak the chemistries and start changing things, but like there's so many unique process ways that we can adjust those things, right? You turn up the heat a little bit, you add a little bit more chrome, right? And I honestly think that's probably going to be, they call it functionally gradient materials, right? That's the name for it. You're seeing a ton of research on it right now, and I think personally, in kind of the large scale and in AM space in general, that's sort of the next big thing, right? Is like understanding the right ways in which to layer different alloys together, when to do that, right?
Yeah.
So I'm pretty excited about that personally.
Now, what are some of the pieces or products that get done here at EWI that might work into the consumer goods world?
Yep.
Like what are some of those technologies that might filter out sooner than later?
Yeah, so a lot of the stuff that we had been working on, honestly, in the past, before I was here and then also when I showed up, is we spend a lot of time building what we'll call digital twins of systems, right? And so that's sort of the big thing that I've seen that industry could adopt now, right? Is we're trying to leverage off-the-shelf software technologies that are out there. So we use PowerMill Autodesk for most of our large-scale 3D prints, right? And what it allows you to do is have full control over the robot. You can generate tool paths really fast. You can do a virtual simulation of it and then immediately export it into robot code.
Yeah,
right?
And that comes, like, you can tie Fusion into that,
exactly,
right? Which is free.
Yes,
like
exactly. And so to me, that's part of it. When we first started, they called it like digital welding, right? And so there's so many different software tools that you can already leverage that just make your job easier, right? And Power Mill is great because it's an adapted CAM tool, right?
Yeah,
so anybody who's been a machinist or knows anything about how to use a CAM tool, you should be able to pick it up and learn it, right?
Yeah. And CAM tools are easily accessible now,
exactly,
right? For people like I was teaching in college, and I remember when I first started teaching, you'd have to spend thousands of dollars for licenses for SolidWorks for everybody and all this stuff. And then Fusion 360 came out. It's like, well, hell, like, I mean, now this is free, and you can download it on your phone.
Yes.
Like,
yep. Well, and that's to me like the beauty of it is that it is a great leveling, right? You know, it's a way of kind of bringing that bottom up, right? To be able to say, hey, now we can all do this, right? And so that's the number one, is just being able to digitize and build the tools to digitize things. Kind of on the more research fundamental side about consumer stuff, we're involved in a lot of different process automation, new kind of techniques. So we do a lot of different processes like plasma and TIG, and also we do a tandem. You know, if you do
dual wire,
dual wire systems. You know, our laser group kind of designs their own optics and is working on. They've got their own coaxial laser head that they're doing 3D printing with, and so those are the type of process things that we try to layer in. But I think kind of on the fundamental, the consumer side, there's so much space now with, you know, and thankfully it's getting a lot of play with like AI and all of that kind of the digital tools that are available. Being able to leverage that data that you're collecting within any process and being able to apply it, I think is something that everyone should be doing.
Well, you know, I think that society in itself is adapting it whether they want to or not, right? Like you're looking at 3D printers being sold at Home Depot, right? And you got kids, 9-year-old kids, 10-year-old kids that are learning to do tool paths. And I mean, you don't tell them that they're doing tool paths, but they do a little CAD, they put it in a 3D printer, and they're printing off their toy or their bases for D&D, their figs or whatever.
Yep.
Like I bought D&D figs off a kid online, and they were great.
Yeah.
Right? And this is like a 14-year-old kid that's, you know, like playing with a 3D printer. And those children, that new generation coming up that's comfortable with the software, comfortable with the idea that you can literally imagine something and create it. That's it.
Yep.
Right? Those are going to be the people that are going to be moving into this sector to be the producers of these products. And it's not going to be a big switch.
No. And I will tell you, that was me, right? Growing up, I loved the video games. I loved playing. I loved all that kind of stuff. I think I started using an FDM printer in 2011, right? So it's been working on that for a long time. So when someone says, "Hey, do you want to do this with metal?" You're like, "Heck yeah, that sounds awesome."
Now we're getting for real.
Yeah, and I think it's a good thing because it's exciting, right? And I think it's a new technology. You know, you get to make your own toys, right?
That's right.
And so I think kind of the way of selling it and seeing, knowing that that's the direction we're heading, that's what we have to do. We have to embrace it. It is a big change, right? When it comes to the traditional manufacturing industry, but we have to embrace it as new technology holders and kind of trying to lead people on to the next technologies. I think it's important to do that.
Now, within your career, if we use that as a basis, to the people that are watching this and they have these fears of the trades disappearing, being replaced by automation, like these kind of common threads that you get thrown at you all the time, which we know statistically isn't really how it plays out. Yeah. But for the ease of mind, we talked about the kid who learns to 3D print and understands that world. Then in your world, you had to come in the same basis and learn welding. How difficult is that? Is that something that, we should be telling our youth, like, hey, learn the technology, learn this stuff, pick up a trade, they'll fit, right?
Yeah, no, I try to every day, I'll say, go down and, we have great welders, our technicians that we actually have doing manual welds and testing stuff, Tim Moore and Stacy Smith and all of our Josh Shoemaker and Joe Getchin, our technicians. And I try to talk to them every day because they have been doing it for so long, that inherent understanding of what an arc should look like, right? And as
sound like, smell like,
exactly,
yeah.
exactly.
Yeah.
And and I'll never forget, like, just funny anecdote. The first project I had here was doing that plasma DED, right? And I go down there with Tim Moore and we're working on this, and I just done gas mill arc welding with large scale, right? And most of that is. It's easier to be robotically controlled, right? So we're trying to dial in this plasma welder, and I had never plasma welded before. And I'm just staring out there under the hood, and I remember like looking at Tim Moore and just going, "So how do you know if it's good?" And he just goes, you'll know if it's good. And I'm just like,
okay,
sounds good.
When we get there, let me write some numbers down.
Yeah, exactly. But I think that's it. Is you need both, right? You
both,
and it helps to have at least exposure to both, right?
Yeah.
And so like that's what I've been very blessed to be able to have that opportunity to have people like that with all this amazing process expertise that I can go ask those questions to, right?
Mm-hmm.
But also I want to bring them my skill set to say like, hey, your wire feeder, you're doing this all manually. Like, can I put a motor on it and just do it for you, right? There's always that. How can we bring enough of differing ideas together and learn from each other and make it better?
Yeah. So if you were trying to do your 30-second pitch now to the world, right, about why we need to be looking at large-scale manufacturing, DED, additive manufacturing, all these things. You got an industry out there that may be sitting on the fence of maybe I go there, maybe I don't, or maybe we scratch that surface. What would be the pitch that you would send out?
Yeah. I really think the pitch is, we need to, right? And, from a defense standpoint, right, we're falling behind, right?
Yeah.
I would just say that straight up, that the U.S. needs to bring back manufacturing and needs to be able to onshore that on ourselves. And this is the future, right?
Mm-hmm.
And it's going to make things more efficient. It's going to hopefully make the company and people more money. It's going to make things safer, right? Yep. And it's going to make things more sustainable, right?
Right.
That's really it when it boils down to it. So we, in my mind, we sort of have a ethical way to do it, but also realistically, if you're not innovating and improving, why are you trying to do stuff?
Yeah, there's a professor out of Denmark, Patricia Holzer, who talks about large scale manufacturing in terms of social responsibility.
Yeah,
and I loved that connection of being like, we want to reinforce our social networks, our infrastructure. Before you start thinking about there, let's do it here. What's our company doing? What can we do to reduce our power input, and create more product, create more jobs, be safe, all these things. And technology really is that pathway.
Yep, exactly. Yeah, and that's what's great about working here is I get to see all that, right? And I get to understand, and at least I have a vision of what is there and what is coming. And I think people understandably are afraid of change, right?
Yeah.
And like, you should be skeptical of change, right? But at the same time, you should also embrace the change, right?
Skeptical is one thing, but don't run away.
That's right.
Like, stick around.
That's right. That's it, right? And, be willing to push it and look at it and say, hey, where would this fit, right?
Yeah.
So that's just sort of where I feel very strongly about it, is just seeing kind of the wide industries of what happens. We tend to get a little caught up in our own little bubble and saying like, oh, I do it the best, or I know the best, right? But in a lot of ways, you should be looking around and seeing how your competition does it and trying to innovate faster than they are.
Competition breeds excellence, right?
That's right.
As we see with college football.
We
won't go there. We won't go
I
there.
know.
No.
Go Balls.
So to wrap up the interview, from your own personal journey, your own experience, coming up in your education, coming here to EWI and the projects you're working on, what would be some advice to say some young kids that are thinking about, looking at the technologies or being interested, or maybe they are a gamer, or maybe they are a computer kid and everyone's saying, oh, you're wasting your time. What kind of advice would you give the next generation?
Yeah. I mean, two things. One is like, do what you love, man. Like that's, I started in in the biorobotics and but I realized that I just love robotics, right? I loved automating something and being able to build that control scheme that makes something work, right? And so just do what you love. A lot of people say that, right? And two is don't be afraid to ask questions. Like that's something that I know personally was a big issue of mine, right? Growing up is just, you feel like you're not worthy, or you feel like, you don't have enough knowledge to understand things. But the only way you're going to get that is by asking those questions, right? And just trying to learn as much as you can, right?
There's a fear of asking questions, but in my experience, and I'm sure yours as well, people are ready and willing to answer.
Exactly.
It's like, why didn't I ask sooner? They were so helpful.
Yes.
Right?
Well, and that's it, is like, again, being a robot guy at a welding place, right, or a process expert place, I've had to ask a lot of questions, right? And so I got over it pretty fast. but once you realize we're all in it together and we're just trying to work on the same thing and make it better, and honestly, sometimes you bring a different thought that they haven't been able to think
Everyone's perspective is valuable and
yes.
and different, right? So
yeah.
Well, this has been a wonderful interview. Thank you, Logan,
Thanks.
for taking the time to
Yeah, no
sit here with
problem.
me.
Sounds great. Thanks for having me.
Awesome. And for all the people that have been watching the episodes and following us along here at EWI, thank you for checking out the podcast. Make sure you check them all out. They're fantastic. I learned a lot this week, and I had a great time here in Columbus. And make sure that you download, share these podcasts with your friends and family. All right, and I'll catch you at the next one, and have a great day.